Hello, myself Neha Memani. I am here to present the problem statement. AI powered suspicious human activity detection for military and border surveillance with multispectral thermal vision. The problem statement ID is SIH25135 and the team ID is 59324. Our team name is Indy Sentinels. India span across 15,000 kilometers of the borders where traditional CCTVs and manual patrolling fail in adverse and harsh weather conditions. So there are thermal cameras that detects the objects using the heat signatures, and we aim to detect and track the IDs of the human in those thermal cameras because thermal images are usually very noisy and unclear. This is the source of the Pathankot attack of Wikipedia that says that six heavily armed people were dressed in Indian army that breached the security perimeter of the airbase in Pathankot. The main objective is to create a surveillance system that actually detects and captures the human and the suspicious activity in real time, even in most adverse weather conditions in low light and during the thermal imaging. And that can also be deployed in the resource limited areas like the military sites. And this is the workflow of our project. The data is collected from the two sources, LLVIP and the FLARE radars, and then those are pre-processed and split into train, test and validated. For this, two models are selected, that is ULOV and 11N and RTDTR. It is a lightweight model and it is a transformer based model. These models are then trained and then evaluated. For the inference architecture, we can input any feed, that can be thermal feed, or the RGB feed, that can be any low light feed, and then the models will be loaded, and then humans will be detected and tracked over the multiple frame, that is the IDs of the human will be maintained. The YOLO V11 architecture is something as follows, that has three components: backbone, neck and head. Backbone has the basic convolutional layers that extracts the features, and then those features are used as input in the neck part, where all the features are merged together, and then those features are gone into the head part where actual detection occurs. The bounding boxes and the class labels are predicted. So that's how the YOLO V11 architecture is flowing. And for the RTDTR L is the large part of the architecture, where the input is used and then the input is flown into the backbone layer that has the convolutional layers that extracts the features, and the max pooling layer that downsamples the features, that is, it reduces the size and dimensionality of the features. Then these features are gone into the P2CCPF layer that actually works as the feature blender, which merges all the features together, that are then used by the IOU aware query selection, that actually selects the most appropriate and the best features for the object. And then the decoder head is used to detect the class of the object and predict the bounding box of the objects. So that's how the objects and humans are getting detected from these two architectures. For the data sources, we have taken the data from the two sources, that is the LLVIP data, that is low light visible and infrared image pairs, for the human detection in the night vision and in the thermal imaging. And for the FLARE radars, the data is used from the FLARE thermal camera that has the RGB and thermal images that were captured in day and night. Also, the number of total number of images approximately in LLVIP are 30,900, and in the FLARE radars it is around 4 lakh images. And the sources of these images are from this is the source for the LLVIP dataset, that is from this source that has actually the image pair. Every image has two corresponding images of the thermal, and it's the same image in the low light night vision, so that model can learn to capture the humans or the data in every domain. And for the FLARE radar dataset, this is the source. It is used from the Tendelin FLARE data, and it had actually 15 classes for it, but we have only used, yeah, these are the 15 classes, but we have only used the category 1, that is the class ID of the person. Several experiments were conducted to test the goodness and accuracy of the model. And these are actual results of our model. As you can see, the green bounding boxes where humans are actually getting detected in the thermal images. Along with that, their IDs are also being tracked. For that, the InfraVisNet L model, that is the YOLO V model, YOLO V11 model trained on LLVIP dataset was used, and the results are by results are generated by inferencing that model. For the tracking part, the byte track algorithm was used. This is actually an input video. This was actually in video where the frames were extracted from it, and as you can see that the idea of the human across the multiple frames remains constant. For the heat map generation, this was tested to see where our model actually focuses on while predicting the bounding boxes. So you can see that the humans with the high temperature are getting highlighted and detected in the image as well, so that our model clearly distinguish between the human and non-human objects. For the activity recognition, the LLVIP pose point was used. The aim of it actually was that to extract the 17 landmarks out of the human and to predict the activity, that is to recognize the activity of the human in case if it is a suspicious activity like crawling, hiding or loitering, so the alerts can be sent to the higher authorities. So the main aim was not only just detect the humans but also recognize their activity along the border sites. For the statistical results, two models were there, YOLO V11 and RTDTR model was there, that were trained on two data sources. So we trained total 4 models, and for the results we have used the InfraVisNet L model trained on LLVIP as said earlier, and because it had higher precision of 91.9%, recall of 85.2%, and MAP 50 of 92.2%. When this model was compared with several other models, we analyzed that our model was outperforming existing models, and also it outperformed existing models with approximately 57.8%. This was the video that was taken to test the accuracy of our model, and this video was taken from this source. This is a official YouTube news channel, and this is an actual India-Pakistan border video. And in this video, you can see that the traditional thermal cameras clearly failed to detect the humans breaching the security at the borders. So our model successfully detected the humans. As you can see, the green bounding boxes over the terrorists that are getting detected. So I hereby conclude our work by providing a reliable solution for the real-time military and the border security by sending alerts to the authorities whenever the human or suspicious activities are getting detected at the sensitive areas, so that security breaches like Pathankot and Pulwamas cannot be repeated again. Thank you.
रात के अंधेरे में थर्मल कैमरे में कैद हुई ये तस्वीरें भारत पाकिस्तान बॉर्डर की हैं। थर्मल कैमरे में जो छोटी छोटी इमेज दिख रही है वो असल में आतंकवादी हैं। उनकी नापाक हरकतें बीएसएफ के कैमरे में कैद हुई तो एक बार फिर से पड़ोसी मुल्क की दोमुही सोच और कमजोरी दुनिया के सामने आ गई। 11 जुलाई की ये तस्वीरें सांबा सेक्टर की मनिहारी पोस्ट की हैं।